Let me solve one more problem about divided difference. But before that, let me ask to subscribe to my channel and please watch the videos online. Okay, let me state the next problem. The problem is, let f of x be a given function. And x0, x1, 2, xn be n plus 1 distinct nodal points. Now, if we define g of x equal to f of x0, x1, 2, xn and x, okay, we now, to prove that, g prime of x is equal to f of x0, x1, 2, xn, x and x. Okay? In fact, the divided difference for x0 to xn, x and x. This is the, in fact, the desired result that we want to prove. Now, let me try to solve the problem by induction on n. Proof by induction on n. Okay, so let me, for the simplicity, define a function, namely g of x equal to f of x0, x1, 2, xi and x. Okay, now let I be equal to 0. So g0 of x is equal to f of x0 and x. Okay, I want to prove that g prime 0 of x is equal to f of x0 and x and x. Okay, we will show g prime 0 of x is equal to f of x0, x and x. In fact, I have to show this equality. Now, to this end, I have to compute two things. First, I have to compute f of x0 and x, and then then differentiate from x about x, okay, with respect to x, in fact, and then I have to compute f of x0, x and x, and these two, in fact, terms should be equal. We have to compute g prime of x and f of x0, x and x. Okay, let me start to compute these two materials. First, let me compute f of x0, x and x. Okay, let me start. Consider f of x0, x and x. This is equal to, by the definition of the divided difference, this is equal to fx and x minus f x0 and x over x minus x0. Okay, but if you consider f of x and x, this is equal to limit of f x and x plus h when h goes to 0. Okay, and this is equal to limit f of x plus h minus f of x over x plus h minus x over h when h goes to 0, and we know this is by the definition of the derivative is equal to f prime of x, right? This is equal to f prime of x. So this is equal to f prime of x. Now let me call it star and let me continue from here. So this is equal to f prime of x minus f of x0 and x. So it is f of x minus f of x0 over x minus x0 over x minus x0, right? And if you compute this one, this will be f prime of x over x minus x0 minus, and here f of x over x minus x0 squared plus f of x0 over x minus x0 squared. Okay, so let me call it equality number 1. So in fact I proved something like this. I proved this is equal to this, right? I compute this one. Now let me try to compute g prime 0 of x. So consider g0 of x. This is equal to f of x0 and x, and this is equal to f of x minus f of x0 over x minus x0. Okay, if you split this fraction, this will be f of x over x minus x0 minus f of x0 over x minus x0. Now take derivative from both sides. So g prime 0 of x should be f prime of x times x minus x0 minus 1 times f of x over x minus x0 squared, and this is plus f of x0 over x minus x0 squared. If you split the first fraction and cancel x minus x0 from denominator and denominator, you will get f prime of x over x minus x0 minus f of x over x minus x0 squared plus f of x0 over x minus x0 squared. So what I proved? I proved in fact g prime of x here, g prime of x equal to this one. Yeah, this one. Call it number 2. Now compare 1 and 2. The left hand side of two equality are equal. So the right hand side should be equal. So if I compare first and second equality, it gives that g prime 0 of x is equal to f of x0, x and x. In fact, this is true for n equal to 1. Okay? This is true for I, in fact, equal to 1. Now, let I equal to n. So if I equal to n gives g prime, so it will be gn of x be equal to f of x0, x1 to xn and x. Okay? And let g prime n of x be equal to f x0, x1 to xn x and x. This will be true, and let this be true. Okay? We have to prove the equality for I equal to n plus 1. Okay? So we have to prove for I equal to n plus 1. Okay? So let I be equal to n plus 1. So g n plus 1 of x should be f x0, x1 to xn plus 1 and x. Okay? This is the definition of g. So we should compute two things. First, g prime n plus 1 of x and f of x0 to xn plus 1, x and x. And if we compute these two items, and these two items will be equal, so the equality is true for all n. Okay? Now, let me start by this one. Let me start by this one. F x0, x1 to x n plus 1, x and x. Okay? This is equal to, by the definition of divided difference. Okay? This is equal to, first let me do something. Let me write it in this form. I move xn plus 1 from this place to the first place. Okay, so it will be xn plus 1, x0, x1, 2, xn, x and x. Right? It's correct, because we know that in the divided difference I can in fact move every item, every element from its own place to any other places, and the result is not change. Okay, so this will be equal to f of x0, x1 to xn, x and x, minus f xn plus 1, x0, x1 to xn and x, over x minus xn plus 1. Right? But by the in fact assumption of induction, we know that this term is equal to g prime n of x. Okay? This is g prime n of x. So we can split this fraction into, so it will be g prime n of x over x minus xn plus 1 minus, and for this one I used the definition of the divided difference, so I will get f of x0, x1, 2, xn and x minus f of xn plus 1, x0, 2, xn over x minus xn plus 1 over x minus xn plus 1. So it should be squared. Okay, it will be squared. Now keep the first term, so it will be g prime n of x over x minus xn plus 1. Okay, for the second one, this one is equal to g of x. This one is equal to gn of x. Okay, so I can write minus gn of x over x minus xn plus 1 squared, and the other one is plus f of xn plus 1, and of course I can move again xn plus 1 from the first place to the last place. It will be x0, x1, 2, xn and xn plus 1 over x minus xn plus 1 squared. Okay, so in fact I proved something like this. I proved this is equal to this. Okay, let me keep it here and let me call it number, or let me call it star. Okay, now it remains to compute g prime n plus 1. First I have to compute gn plus 1. gn plus 1 of x. By the definition of gn, it will be x0, x1 to xn plus 1 and x, right? So again, I move xn plus 1 to the first place, so it will be f xn plus 1, x0, 2, xn and x. Okay, and now I write the definition of the divided difference. So it will be f of x0 to xn and x minus f of xn plus 1, x0 to xn over x minus xn plus 1. Okay, now by the definition of g, this is equal to gn of x. Okay, so let me write and split the fraction gn of x over x minus xn plus 1, okay, minus f, and I move xn plus 1 to the last place again, x0 to xn and xn plus 1 over x minus xn plus 1. This is okay. Now if I compute g prime n plus 1, so g prime n plus 1 of x, it is equal to g prime of n, g prime n of x times x minus xn plus 1 minus gn of x over x minus xn plus 1 squared, and the other one, this is a number, so it will be f of f of x0 to xn and xn plus 1 over x minus xn plus 1 squared. If I split the first fraction and I cancel x minus xn plus 1 from denominator and denominator, I will have g prime n of x over x minus xn plus 1 minus gn of x over x minus xn plus 1 squared plus f of x0 to xn and xn plus 1 over x minus xn plus 1 squared. So I proved so far something like this. G prime is equal to something like this. Right? Call it number 2 star effect. 2 star. So look, the right hand side of star and 2 star, double star are equal. So the left hand side should be equal. So I can, from star and double star, I can conclude that g prime n plus 1 of x is equal to f x0 x1 to xn and xn plus 1 x and x. And these complete the proof. The proof is a little tricky and you have to be very careful when you compute some items and when you in fact compute the derivative of some functions. So please subscribe to my channel and wait for the next lectures and more problems, and please watch the videos online. Thank you.